You've seen it in movies, those sleek, futuristic interfaces that respond to the slightest touch or movement. Wave your hand, and a holographic display comes alive, shimmering with information. It seems like something straight out of a science fiction blockbuster. For years it was pure sci-fi, a tantalizing glimpse into a future that felt impossibly distant. We could only dream of controlling our world with a flick of the wrist. But now, gesture control is real, and it's rapidly changing the way we interact with technology. Instead of tapping a screen or fumbling with buttons, your body becomes the remote, an intuitive extension of your will. Hands, fingers, a subtle dance of motion, even head movements can control devices, offering a hands-free experience like never before. It's intuitive because we use gestures, these ingrained physical cues, to communicate every day. It's how we naturally express ourselves. Waving hello, pointing to an object, giving a thumbs up to show approval. Gesture control taps into this natural language, this innate understanding of movement and meaning, making tech feel like an extension of your intentions, a seamless bridge between thought and action. We've moved from keyboards and mice, those clunky relics of the past, to touchscreens, a more direct and engaging way to interact. And now, gesture control is the next leap, promising an even more natural and intuitive experience. Imagine controlling your smart home, adjusting the lights and temperature with a simple gesture, or flipping through recipes with a wave, all without ever touching a screen. And best of all, no more dirty screens, just clean, effortless control. But how does it work? What's the secret behind this seemingly magical technology? It's not magic. Though it might feel like it at times, it's clever hardware and smarter software working in perfect harmony. Devices need to see you, to perceive your presence and track your movements, and understand your movements, interpreting the nuances of your gestures, using sensors and algorithms to translate your actions into commands. This tech is moving from labs to living rooms, from specialized applications to everyday devices, showing up in more places than you might expect, quietly revolutionizing how we interact with the world around us. The promise? A future where technology anticipates our needs, seamless, almost magical interaction with our gadgets, making our lives easier and more intuitive. As gesture control gets better and cheaper, as the technology becomes more refined and accessible, it's becoming part of everyday life, seamlessly integrated into our homes, our cars, and our workplaces. The sci-fi dream is closer than ever, and the future of interaction is at our fingertips, or rather, in our gestures. Let's see how your moves get seen, and how this technology is making its way into our lives. For a device to understand your gestures and translate them into actions, it first needs to see them, to perceive the nuances of your hand movements. This initial step is crucial. That's where sensors come in, acting as the eyes and ears of the device. Most common is the camera, like the one on your phone, a ubiquitous tool for capturing visual data. It's capturing 2D images, providing raw visual information for sophisticated software to analyze and interpret. But cameras struggle in low-light conditions or when the background is too cluttered, hindering accurate gesture recognition. Enter infrared sensors like those found in the Xbox Kinect, offering an alternative approach to visual sensing. They project a grid of IR dots and read the distortions to build a 3D map of the environment and your hand, adding depth information. This technology works well in any lighting condition, providing reliable gesture tracking regardless of ambient light. Then there's radar, now miniaturized for integration into devices like Google's Solly chip, a marvel of engineering. It can detect even the tiniest motions, even something as subtle as a finger rub, opening up new possibilities for interaction. It achieves this by bouncing radio waves off your hand, analyzing the reflected signals to infer movement. Radar has the unique ability to work through certain materials and doesn't require a direct line of sight, adding to its versatility. Each sensor technology has its own set of pros and cons. Cameras are relatively cheap and easy to integrate. IR sensors give depth information, enhancing the accuracy of gesture recognition, while radar offers unparalleled precision in detecting subtle movements. The choice of sensor depends heavily on the application and whether you need to track large arm waves or subtle finger movements with extreme accuracy. These sensors, in their various forms, are the fundamental building blocks of gesture recognition technology. As technology continues to advance, we can expect to see even more creative and innovative uses of these sensors in our everyday devices. Selecting the right sensor is what makes reliable gesture control possible regardless of the surrounding environment or lighting conditions. Next, let's delve into the fascinating process of how your movements are translated into digital commands that your devices can understand and execute. Capturing your movement is just the start. It's the initial step in a much larger process. The real magic, the true intelligence, is embedded in the software that powers these interactions. Computer vision algorithms are the unsung heroes, working tirelessly to identify and track your hand in real time, meticulously analyzing video frames or depth maps to understand its position and orientation in space. They lock onto your hand, creating a digital representation of your physical form, follow its path through the air, recording every subtle nuance of its movement, and calculate its position, speed, and direction with incredible precision. This allows the system to differentiate a quick swipe from a slow, deliberate point, understanding the intent behind the action, all in milliseconds, making the interaction feel instantaneous. Powerful processors are absolutely essential for this real-time analysis. Any lag or delay completely ruins the experience, breaking the illusion of seamless control. Computer vision meticulously breaks down images into key features, identifying the elements that define a hand gesture, finger edges, palm center, and overall hand shape. The ultimate goal? To turn your fluid, natural motion into structured, understandable data. Precise coordinates and angles that the device can interpret and act upon. So, instead of a traditional mouse click, a physical action with a dedicated device, your hand closing into a fist, a natural and intuitive gesture, becomes a command. This seamless translation from the physical world to the digital realm is the very core of gesture control technology. The better the software algorithms, the more natural and intuitive the interaction ultimately feels. It's a remarkably complex process happening behind the scenes, but when it all comes together and works flawlessly, it feels almost like magic. Now let's delve deeper and explore how the system accurately recognizes and classifies the specific gesture you're making. Recognizing a gesture isn't just about tracking your hand, it's about understanding its pose. The system maps key points, fingertips, knuckles, palm center to create a skeletal model in real time. By analyzing these points, it distinguishes a thumbs up from a point or a fist. Machine learning models are trained on massive data sets of gestures from people of all shapes and sizes. The more data, the smarter and more accurate the system becomes. This training lets the system tell intentional gestures from accidental ones, making interactions fluid and reliable. That's how gesture control feels so natural when it works well. Gesture control isn't just a lab experiment, it's in products you can buy. In AR and VR headsets like MetaQuest and Apple Vision Pro, hand tracking replaces controllers for immersive experiences. Some smart TVs let you change channels or adjust volume with a wave, no remote needed. In cars, brands like BMW and Tesla use gestures for safer, hands-free controls like adjusting volume or answering calls. Early devices like Leap Motion paved the way for today's applications. Gesture control is moving from novelty to necessity, essential in VR, convenient in cars, and promising in the living room. The key is using gestures where they truly add value over buttons or touchscreens. As tech improves, expect gesture control to become standard in more devices. It's about making interaction easier, safer, and more intuitive. Now let's talk about accessibility and why this tech matters for everyone. Beyond the cool factor, gesture control is a game changer for accessibility. For people with disabilities, it offers new ways to interact with technology, like controlling a cursor with head movements or simple waves. Designing for accessibility often leads to better products for everyone. Think voice control or automatic doors. The pandemic highlighted the need for touchless tech. Gesture control lets you use elevators or kiosks without touching public surfaces. It's not just about convenience, it's about health and inclusion. Gesture control is building a more accessible, hygienic, and user-friendly world. The real value is in making technology work for more people, in more ways. So, what's next? Gesture control is becoming a standard feature, not just a novelty. Hardware is smaller and smarter, software is more reliable, and AI is making interactions seamless. The future? Devices that understand not just gestures, but your intent, anticipating your needs. Challenges remain, standardizing gestures, ensuring privacy, and making systems nearly flawless. But as reliability improves, gesture control will feel as natural as talking. It's about making tech more human, breaking down barriers between us and our devices. The sci-fi future is finally here, and it's literally in your hands. Get ready for a world where a wave or a point is all you need.